Hey guys, so this is day 5 of our Unit 1 packet. We're going to talk about a new vocab term today, and it is the midpoint. Okay, midpoint is a point on a line segment. So yesterday we talked about, right, how a segment, or sorry, not yesterday, a few days ago, we talked about how a line segment has two endpoints. Okay, and then a midpoint is a point on that line somewhere. Okay, but it divides the segment into two congruent parts. So here's a diagram below, right? I have a segment A, B. Okay. I'm going to put a point in the middle and I'm going to call this just M for my midpoint. Okay. It cuts this segment basically in half. It divides into two congruent parts, congruent or, right, equal parts. So that would tell me, right, AM would have to be congruent to MB. Okay, we've talked about that notation. I have AM with my segment bar on the top, right? This means congruent. Okay, and then MB. Now, when we look at this, right, just like I was just saying, if we see something like this in a proof, okay, given M is the midpoint of AB, so this is basically like the diagram above, what would I say? Well, my conclusion, right, would be that AM is congruent to MB, right? Kind of talked about that above, but this is how it would work in a proof. Okay. When we think about the applications, this is more of what we've been doing lately, right? They tell me M is the midpoint of AB, right? So I have this line just like above, M, A, B. AM is 2x plus 1, right? And BM is 3x minus 4. So they want us to find the length of AM, BM, and AB. Okay. Now, the reason I know length is what they want us to find, right? We want to find the length of each, okay, is because when they use the segment bar, it's just naming the segment. But if they don't have the segment bar over the top of the letters, like in my bubble there that I circled, that just means they're talking about the actual physical length. Okay. So we should associate a number, right, with the notation where I don't have the segment bar above. Okay. So the way we would solve this is if I have 2x plus 1 as AM, well, my midpoint tells me that these two segments are congruent, or another word for that would be equal, right? So 2x plus 1 equals 3x minus 4. Now I can go ahead and solve for x just like a normal equation. I'm going to add 4 to the left. That would give me 5, and I can subtract my 2x over. That just gives me 1x. So x would be 5 if I solve this equation. Okay. Now they want to know what AM is. Well, AM is 2x plus 1, right? So 2 times 5 plus 1, that's 11. Now you shouldn't even have to go and plug in to MB, right? Because if it's the midpoint, we know MB is also 11, okay? Which would make the whole segment, right? We talked about segment addition in another lesson. I'm just going to add those two things together and I would get 22. Right, so there's how I would answer that question. Now, you might also see some representations or some applications graphically. Okay, so they gave us a chart. They want us to plot some points and find the midpoint. Okay, so on point A, 1, 1, 2, 3, 4, that's this point right here. And B is 7, 4. So 1, 2, 3, 4, 5, 6, 7, 4 is right here. They want us to find the midpoint. So the midpoint would be halfway in between. So the length of this whole segment is 6 of the boxes, right? 6 units. So my midpoint would be in between, right? I'd have 3 units on the left and 3 units on the right. So my midpoint would be 4, 4. Okay, basically just counting halfway in between. Then they give us a couple different points. So I have 3, 1. Let me switch colors. 3, 1 is right here. And 3, negative 3 is right here. So let's find the midpoint of this. Well, this whole length is 4 units. So directly in between would be 2, and that is 3, -1. Okay, so it shouldn't be too difficult. Now, sometimes where it gets difficult, maybe I would have a point here and a point here, right? We can't really count along that slanted line. So sometimes we're going to need a formula. Now, the formula for midpoint looks something like this. So it's saying M, or the midpoint, equals, and it's actually going to look like a coordinate, okay? So I'm going to take my x1 plus x2, and I'll explain what all this means in a second, over 2 y1 plus y2 over 2. So I'm going to scroll back up for a second, but if we think about these points, right? Finding the middle value of my A and B here, right? That's just like taking the average. So if I looked at those X values, so thinking about our formula, this would be X1, Y1. Point B is going to be X2, Y2, right? So thinking about our formula, if I look at M, is, well, I have x1 plus x2. So I'm going to take 1 and 7 over 2. And then the next part is y1 plus y2. So 4 plus 4 over 2. Okay. I can go ahead and now simplify that. So 1 plus 7 is 8, divided by 2 is 4. And 4 plus 4 is 8, divided by 2 is 4. So notice we get the same point we found by counting, but it'll even work for our slanted lines. Okay. So basically, sorry, my computer scrolled on me. So when we look at this formula, it's going to say my line segment has endpoints. You might have A, which is x1, y1, and B, which is x2, y2, right? So then you can go ahead and plug the x1, y1 and the x2, y2 into your midpoint formula. Okay, so let's practice. So find the midpoint, right? And they give you these endpoints here. So I'm going to say, okay, well, here's my formula. X1 plus x2 over 2, y1 plus y2 over 2. Basically, I'm finding the average, right? So I'm going to plug in. My A would be x1, y1, and my B point would be x2, y2. Okay. Now I know there's gross fractions here, but I would have 2.5, okay, plus 3.25 over 2. And then I would have 1/4 plus a -1 over 2. And you guys can go ahead and type those into your calculator, right? You could also rewrite them as decimals. So 2.5 plus 3.25 over 2, right? 0.25 minus 1 over 2. And type these individually into your calculator to simplify that. Okay, I'm not going to go ahead and do that, but you guys can on your own. Okay. Now, where this gets challenging is something like example 2. Okay. They actually give you the midpoint this time. So the midpoint of DG is M. So when I think about my formula, just take a second to write it down. What I know is that I have M, right? So I have a point on this left side this time. I'm not going to leave it as an M because I know what the midpoint is. And I have one endpoint. So this is x1, y1. So let's just go ahead and plug in what I know. I have x1, which is 1, but I don't have an x2. Okay, I do have a y1, but I don't have a y2. So now I have this weird looking equation that you guys probably have never seen. Okay. What we have to think about though is the only way that this equality is true is if what's on the left is the same as on the right, right? I have to have this midpoint on the left, but my right eventually also has to equal the same thing. So what this tells me is this whole part right here, I want to be equal to -1 so that that equality is true, so that I don't have something that's false, right? So I need -1 to be equal to 1 plus x2 over 2. And when I think about the second part of this, I need my 4 plus y2 over 2 to equal 5. So I have 5 equals 4 plus y2 over 2. Okay. So now don't let the subscripts on your letters freak you out, right? It's basically just like solving an equation now, right? I'm going to multiply the 2 to the left, so I have -2 equals 1 plus x2. I'm going to subtract that 1 away, so -3 equals x2. Okay. Now let's think about the next one. I'm going to once again multiply 2 to the left side. 10 equals 4 plus y2. I'm going to subtract the 4 to give me 6. So what this tells me is my other endpoint, my endpoint G has to be, well, a coordinate, of course, because it's a point. So the x value of the coordinate is -3 and the y value is 6. Okay. So take a second to just kind of let that example run through your brain. Go back and repeat and watch it if you need to again. Okay. But that's all I want to cover in this video. We'll talk about the rest in class. Thanks for watching.